Okay, thank you very much initially to those who've invited me to come to this very prestigious event. Thank you very much. And I really appreciate the opportunity to talk about the fourth industrial revolution and how it affects innovation or is affected by innovation. And thanks for so many people coming, despite it being the rainy season, which is much rainier than it is in England at the moment. In this talk, I'm going to first of all introduce the ideas behind the fourth industrial revolution and then explain why innovation is an absolute necessity if businesses and countries are going to survive this revolution. I will then introduce some approaches to looking at how to innovate, looking at how to understand innovations of the past, and suggesting some areas of innovation that we need to look at in the software quality area and investigate their feasibility for the future. So, if we look at past industrial revolutions, I feel quite happy coming from the United Kingdom because the first industrial revolution started in England with the invention of high power steam in about 1760, and the ability to create lots of energy in a very small space allowed factories to be built. This of course meant that all of the people who were working in their cottages, in small villages, their products were now suddenly much too expensive, and it made an enormous social change. So lots of these people now had to move to work in the factories. If we were to move on about 100 years to the second industrial revolution, again, part of this started in the UK with the invention of steel, then what we see is things like steel coming along, the ability to build big bridges, railway lines. The railway lines gave us good communication, and then later in this period we had electricity. As soon as we had electricity, now we have the ability to do mass production, because before electricity it was really difficult to light the factories at any other time than in the middle of the day. Third industrial revolution, I'm afraid to say, was actually in my lifetime, so in the 1970s. And with the 1970s, we saw IT and electronics coming to the fore. And for most of my career, many of the jobs I've been doing have been automating away people's jobs. So if you were a secretary or a bank clerk in the 1970s, there's a really high chance now that you do not have that job anymore, because we as IT professionals have automated it away. So, what about the fourth industrial revolution? Well, we have the fourth industrial revolution coming from two different places. On the right there on the slide in the title you see Industria 4.0. So in 2011, the German government decided to put lots of money into smart factories. So this was probably the true start, but maybe a bit early. And then in just January of this year, Professor Klaus Schwab of the World Economic Forum declared to his group of world leaders that the fourth industrial revolution had started. So what is it? Well, the fourth industrial revolution at the most basic level is having robots working in factories, but not just simple robots, smart robots that can communicate with each other. So we have networks of robots talking to each other and optimizing their production. You'll also notice that the product these robots are working on is also communicating. in your smart factory of the future, the actual products are smart as well. So they might, for instance, have an RFID tag, and that RFID tag will actually allow the system, the product, to communicate with the robots to tell them, for instance, how full it needs to be, what colour it needs to be, so it can describe particular attributes that that product needs to be. Sorry, excuse me while I fix the screen at this level. Apart from the robots are one form of cyber-physical system. We also get lots of other types of cyber-physical system. So typically, one of the ones that's in the news a lot at the moment are autonomous cars. There, we've got a smart enough car to actually drive without the driver. Not on the road yet, but will be in the near future. Also, we have things like smart grids, where we actually have computers controlling the electricity grids. So we have lots of opportunities. It's a question of, are we actually there yet? Well, if we take robots as an example, what we can see on this slide, you may have heard of Foxconn. Foxconn is a Taiwanese company. They have many employees, over 1 million employees. And you can see there at the top of the slide, in 2012, their plan was to put in 1 million industrial robots over the next 3 years. Well, in 2016, the reality is that it's probably closer to 100,000. But the idea is there. However, that has had a big effect on some of the Foxconn workers. In just one factory in May this year, 60,000 Foxconn workers were made redundant because they were replaced by robots. So that has a big social impact. Now, Foxconn is producing electronics for companies like Apple, Sony, Microsoft. Korea is the #1 user of robots in that part of the industry. Korea has the highest density of robots working in the electronic sector. Actually, the automotive sector is the biggest user of robots, and you can see that 43% with the latest figures there are actually being used for automotive industry. The predictions are that many more robots will actually come along. So if we have many more robots, what will the effect be on the workers? I guess we could ask one of the 60,000 workers who lost their jobs in China and see whether or not they found it easy to get another job. I suspect not. In an ideal world, we would have salaries that covered the whole spectrum, from low-paid jobs with low skills to high-paid jobs with high skills. And of course, we have the whole spectrum because we have some people who are moderately skilled and we pay them somewhere in between. By having this whole spectrum, it's easy to control and manage our workforce, because people who come in at any particular level perceive there to be the possibility of progressing up this spectrum, gradually moving, if they start at low skill, gaining skills and moving up the spectrum. If we introduce robots, however, we have a problem, because the robots don't take many of the lowest skilled jobs. Many of the lowest skilled jobs are doing things like pulling out weeds in gardens. Robots don't do that. Robots are actually good at taking out the moderately skilled jobs. The economist, American economist Tyler Cowen, actually believes that average will be over with the fourth industrial revolution. That as we automate the jobs, what we'll find is that we've taken out that middle layer. Now we have a problem. If we take out the middle layer, where do those workers go? And if we take out the middle layer, there is no obvious progression from the bottom layer to the top layer, which is not going to be good. Of course, this effect is much worse for countries that have a big industrial base. The widening social gap will cause tensions, and what we'll find is that governments have to do something to actually cope with this. Education and investment in innovation to actually make sure that we can actually increase the green bit at the top there to include more people. If we have that gap in the middle, we've also got a gap in our sales, because the people who sit in the middle there are the people who buy many of our products. If we push them all down so they don't have much money, then we're losing sales. So we have a slight problem. On the other hand, industry accounts for less than half of GDP across the world. Most of GDP is service. So maybe all these robots aren't a real problem. Unhappily, or perhaps happily, depending on how you look at it, the fourth industrial revolution isn't just about robots. It covers lots of other technologies as well. So I've put a selection here, and hopefully you should recognize most of these and be aware of how they affect your jobs or are likely to affect your jobs in the future. You'll be using some of these already. Many of you will have wearable devices already. Most of you, I assume, will be using cloud technology. However, some of these you might not be so aware of. And for instance, when I was doing some research into these different technologies, one of the things I was surprised at, I looked at 3D printing. To me, 3D printing is much of a toy, a gadget that I am tempted to buy for my son, but it's too expensive. But then when I looked at 3D printing, I looked at Boeing making airliners and military aircraft. Boeing are currently creating 20,000 different parts to fly on 10 different aircraft. So 3D printing is already there. We have to actually look at each of these technologies and see how we can exploit them. Now, as new technology comes along, it disrupts organizations, because organizations and businesses are already used to making things that they've done the same way for the last 5, 10, 20, perhaps even 50 years. We can see that as technology comes along, it causes disruption. Not many people now travel around with paper maps in their cars, because we all have sat-navs, or we have the ability to look at maps on our phones. I notice that there are still payphones in Korea, but I never see anyone using one. We've all got mobile phones. We don't actually need them anymore. Not many people, or no people now, can rent video cassettes because we just download the films. Organizations have to understand how the technology is going to disrupt their business model and work around it. Now, what you can see is that if you were a business in film photography, then you could see that digital photography was coming along, and you could work with that and start building digital cameras. So down on the bottom right, you've now accepted that technology change, changed your business model, and you now have digital cameras. And you're feeling really happy because you've coped with it. That was a big change for your business. All of your factories had to change. Your business model changes. And then another disruption. Because as technology accelerates, what we see is that digital cameras now are not very popular. Because now, with the better technology, we can put really good digital cameras in our smartphones. And if we can put good digital cameras in our smartphones, why buy a separate digital camera? So if we're a business trying to cope with this disruption, it's not just once. We have to be continually considering how we're going to cope with the changes. So let's look at the UK situation, because I'm most familiar with the UK situation, and use it as an example, because I believe the UK level of economy is similar to Korea's level of economy. I would hope our education systems and technology are relatively similar too. Now, these figures come from last year, and you can see they come from Deloitte, a large consultancy firm. And what they said was that 10 million UK jobs, that's over a third of all UK jobs, are at risk of automation in the next 10 to 20 years. Well, that's really worrying, or it should be really worrying if you're just starting out on a career, because you're going to have to make sure you don't pick the one of the 1 in 3 jobs that's going to disappear in that 10 to 20 years. They also looked back 15 years. And when they looked back 15 years, they saw that technology had already contributed to the loss of 800,000 of the lower skill, higher risk jobs. Not good news. But then they looked at whether or not technology had generated new jobs. And in fact, during that same period, the technology had helped create 3.5 million new jobs. So we lost 800,000, but we gained 3.5 million. And the 800,000 jobs we lost are low skill or high risk jobs. So they're the sort of jobs that ideally we want to lose. If we can move the people into these other jobs, which are higher skill, non-routine, then that's got to be better, because it's going to be more interesting for them and they're going to be happier. Not only will they be happier because the jobs are more interesting, but as you can see from the figures there, for each of those new jobs created per year, on average, they were getting an extra 16 million won per person. So that makes them even happier, apart from having the more interesting job. And of course, as far as the economy is concerned, that then adds up to some, well, I find it difficult to imagine trillions, but 221 trillion won worth of extra money going into the economy. So if we look at this, we might think, actually, this isn't a problem. As long as we've got the right infrastructure in place, the right research and development, the right education system, then maybe we can cope with this fourth industrial revolution. But probably not, because one of the main parts of the fourth industrial revolution is that it's based on velocity of change of technology. So Professor Schwab, when he introduced the idea of the fourth industrial revolution, basically said it's not just new technology coming along, it's not just robots coming along, it's the speed with which the technology is coming along. And if you look at the graph here, you can see that since man first went into space, the rate of acceleration of new technology is amazingly fast. And in IT, we're obviously not immune to this. If we consider something like Docker, so container-based development, Docker only was released as open source in 2013. But now many, many organizations are using it as the basis of their IT development. So that technological change has happened in the space of only 3 years. In IT, we're probably worse off than anyone else. The acceleration will probably be even faster. So we've got cyber-physical systems coming along, lots of new technology, and the rate of change of technology is getting faster and faster. We have another problem as well. And our other problem are the users. If we were to go back 30 or 40 years, our users were nice, compliant users. We gave them computer systems. The computer systems failed more often than not, and the users got used to that scenario. They worked around it. They waited for the bugs to be fixed. They were very patient because we were giving them computers, and that's probably more than they deserved. Our new consumers don't believe that. Our new consumers have grown up with this computer technology, and our new consumers are used to having the ability to choose from a range of high-quality applications. So therefore, their expectations are much higher. Our new users are mobile, whereas before, our users were static. They were tied to a desk. Our new users can be anywhere. And also they expect 24-hour availability. So our systems can't shut down for 4 or 5 hours while we fix things. They have to be ready the whole time. So therefore the quality has to be really high. Also, users nowadays expect transparency and trust. They expect that the systems, when they actually go wrong, the businesses are honest with them about why they've gone wrong. They expect that they will buy more from businesses they trust than businesses who've lied to them in the past. And because of all this extra communication, it's very difficult for businesses to hide their mistakes. As the American government have found, it's very difficult for governments to hide their mistakes because people leak information. And once that information is out there on the internet, it becomes available to everyone. So in the future, we're going to have businesses and government that have to actually provide that transparency because that's what users will expect. That means they're going to have to change. The new users have lots of choice. If they have lots of choice, then we have to make sure we build quality in. One of the reasons they have lots of choice is that small organizations can now build systems really easily using open source approaches because they don't need to build and have all the infrastructure themselves. They can just pull in lots of the code from the community. One of the problems with that, of course, is lots of that code that they pull in from the community isn't especially high quality. So one of the opportunities we have, perhaps in the area of standardization, is to make sure that we provide some way of measuring the quality of that open source software before we put it into business critical systems. Because there's a lot of choice, time to market is really important, and also customization. What we're going to see in the future is the movement of enormous factories with 110,000 employees in China to the local market. Because if we can move robots into our market, and the cost of a smart robot nowadays is about $25,000, we can actually build the products as cheaply in Korea, in Germany, in the UK, in America, as they can be built in China and Vietnam. The cost of a Chinese worker working on a factory line in China at the moment is greater than $5 an hour. The cost of running a smart robot is less than $1 an hour. It doesn't take a lot of thought to think, what would I prefer? A robot that doesn't get ill, is 100% consistent, and isn't likely to leave and want to go on holiday. I can run that robot 24 hours a day. I can't run my factory workers like that. So what we're going to see is consumers wanting customized products. Sometimes they'll actually want to customize the products themselves, and we can build those locally as cheaply as if they were sourced from overseas. This is fine for places like Korea. It will, however, cause big problems if you were a big factory owner in a place where you thought there was cheap labour. If we're going to do this, then we need to put in policies that allow this fourth generation technology to be used well. So maybe we need government to change some of the way it does its legislation. For instance, if we want autonomous cars, the government have to provide us with laws that allow autonomous cars to run on the roads. They also have to, perhaps through the standards agencies, provide regulations to make sure those autonomous cars are safe. Similarly, with all the robots, the smart robots in the factories, and some will move out of the factories, we need laws to make sure that they're safe as well. Government could provide help to industry by maybe making it easier to share information. And maybe, because security is going to be an enormous problem, maybe changing some of the laws to make some of the deterrents for security breaches higher might be necessary to actually help the actual technological guards we put in place for security. As far as the standards are concerned, then we need our standards bodies to actually produce standards quicker. At the moment, to produce an international standard takes about 4 years per standard. With accelerating technology, that's no good. We need something that is much faster than that. So, we can't keep doing the same thing. If we actually look at typical industries over the last century, these businesses lasted for an enormously long time. On average, if we looked at a firm in America, one of the top 500 firms in America in mid-1950s, its life expectancy was 61 years. Today, one of those top 500 firms, their life expectancy is only 18 years. And if we were to go back to 1955 and look at those top 500 firms, what you see is many of them had a product and just kept producing the same product or subtly making it a bit better. They didn't cope with the disrupting technology. And at some point, for 7 out of 8 of those organisations, the technology came along and the technology change was too great. And those businesses went bust and they dropped out of the top 500. In the future, what we'll need are organisations following a different path. We'll need organisations, they start off with a good product, and then they recognise that actually technology change is going to hit them. So therefore they invest in R&D. So we can see here, they begin investing in R&D, and then at some point they change or diversify and add more products. And again, after a short period, and the period will probably get shorter and shorter as technology accelerates, they need to do it again and diversify again. This will be, so we got R&D coming in here, and this model will be very similar to the model that many of your children, or actually many of you, because you look quite young, are going to have to follow for your careers. Whereas 30 years ago, 40 years ago, people expected to have one career and follow it all the way through till they retired, in the future, people are going to change careers 3 or 4 times because technology is going to change, the disruption is going to force them to move into new areas. Let's look at briefly look at a UK example of where this has worked. And at the bottom there is James Dyson, and he's holding his vacuum cleaner. He started with a business that made one thing. And that one thing was the vacuum cleaner, but very successful. He was very good at the testing and very good at failing. He built over 5,000 prototypes before he actually got that to succeed. But he persevered. One of the things about innovation is you fail a lot and you test a lot, but you learn from the failures. And one of the things Dyson appear to have learned is that if they're going to survive in the future, they can't have just one product, and you can see that they've already diversified partly. They're investing in their R&D. So in 2014, they said over the next 4 years, they will invest 1.6 trillion extra in R&D above their usual. And they plan to launch 100 new products in that time period. This year, they've recognised technology is still accelerating. They're actually going to have to put even more money into R&D. Another 1.6 trillion won invested in battery technology, as they see that as where they're going to be. Hopefully, from their perspective, that will allow them to survive. I believe most businesses are going to have to follow a very similar model if they're to survive. They're going to have to go into R&D and innovate their way to survival. Now, many of you, hopefully, are IT professionals in software quality, and you might be thinking, but he's just talking about products there, but innovation doesn't work just with products. It also works with services. So although we have product innovations, we also have service, process, and organisational innovations. So many areas that we can work in. Now, if we want to innovate, one of the ways to innovate is through what's known as Exaptation. Now, Exaptation says what we're going to do is we're going to look at a different industry and try and bring the ideas of that industry into our industry. What you can see there is a picture of a Jacquard loom. That loom is from 1801. The picture on the right is Jacquard, who invented it. The picture on the right, you're thinking, well, maybe you're thinking, oh, that's a really early photograph if it's 1801. But it isn't a photograph. That is actually a picture made with the loom. It was really technologically advanced. And you notice it runs on punched cards. Those who are old enough might remember punched cards from your early days at university. When the first mechanical computer was invented, about 50 years later, in 1850, it used the same technology, punched cards. So here we can see an example of where we take one technology and use it somewhere else. An example of that might be for software, where in medicine we know that if we use evidence-based medicine, we can save many lives. Evidence-based medicine says we pull all the research results and put them together and get a final result and use it. Evidence-based medicine has saved tens of thousands of lives since it was invented in 1990. We ought to be doing the same in software. If we can pool our resources, pool our research, we should be able to make software quality, software engineering, far better. So I want you to introduce the idea of adjacent possibilities. So adjacent possibilities says, okay, somebody has an idea. Once somebody has an idea, as long as there is good communication, lots of other people now know about that idea. Once they know about that idea, they can build on that idea and come up with new innovations. For instance, we can't invent the telephone until someone has invented electricity. Of course, if we now come up with an innovation, other people can work on top of our innovation. Maybe we've invented the computer, now we can invent test automation. It doesn't have to be purely linear. We don't only base our ideas on one source. If we've got one area and then we look at another area, we might find that combining ideas from both those two areas gives us an innovation in a third area. Now, what we can see here with the Gutenberg press, so we're going back now to 1440, so this was the first mechanized printing press, and Gutenberg there came up with the idea not from just basing it on one thing, but from basing it on several other ideas that were already around. For instance, he lived in a winemaking area. So therefore, they had presses for the grapes. So he came up with the idea of reusing that idea for the printing press. He had paper. One of the problems with the paper at the time and the ink was that the ink was water-based, which meant as soon as you printed it onto a piece of paper, it soaked through to the other side. So he invented oil-based ink. And by using oil-based ink, you're able to actually print on both sides. And what we can see at the top there is that if we were to go back 1,500 years, someone invented wood blocks for printing. And then after that, someone thought, oh, it would be a better idea if it was made of ceramic. And then Gutenberg was a goldsmith. So Gutenberg said, actually, it would be better even still if we made them of metal, because then they would last longer and we could make them quickly. In fact, if you actually look at Korean history, what you find is in Korea, metal movable type was invented way before Gutenberg invented it in 1234. But in Korea, you didn't have the presses and you didn't have the oil-based ink, and therefore you didn't have the complete set of innovations required to mechanize printing presses. And of course, the Gutenberg press, very similarly used today. So that brings me to lines of innovation. What you can see with the Gutenberg press there is that we had wood blocks, then we had ceramic type, then we had metal type. Innovations build on innovations. So we end up with lines of innovation. What you can see here is lines of innovation to do with software quality. At the far left there, if we look at the scientific method, that was the 17th century. So a theory of how to do scientific exploration. If we then go to specialized tasks from the Industrial Revolution, we're now saying if we've got mass production, we need people or machines to do just one task. If we move to the 1920s, on top of that, we can now do statistical quality control. After the Second World War, the Americans took all of these ideas to Japan because it was a perfect opportunity to try them all out, and the Japanese didn't have any choice. Of course, coming out of that, we ended up with very good models of managing quality. And in fact, for many of the years since I've been working in IT, we've been following the Japanese approach of using quality with just-in-time, the Toyota manufacturing system. As we build on these models, we eventually end up with CMM, and eventually we end up with process improvement models here. So these lines of innovation allow us to understand how we get to where we are today. We don't just follow a set of rules here, it's based on many innovations over the past. Now, some of you will be doing DevOps. What you can see from this model, just in time, the Toyota manufacturing approach, value chains leading to lean thinking. One of the things that feeds into being able to do DevOps. We also have Agile. We have continuous delivery. We have IT service management down here, because apart from this part down here, all of this is development, or practically all of this is development. If we look at this model, then one of the things we might consider is, well, where does the testing fit in? Where do we put the quality in? Well, we have some here with the test automation feeding into continuous integration, and we have some test automation feeding into the life cycle tool chain. But maybe the next innovation on from DevOps will be adding more testing concepts to combine with our development and our operations. In the UK and America, one of the themes in software quality at the moment is shift left. And shift left is not a new idea. It's based on measuring software. From measuring software, we know that fixing software costs a lot the later we leave it in the life cycle, and therefore we should do testing as early as possible. Since 1980, we've known that the V lifecycle model gives us something along those lines. But shift left says, no, we want more than that. We actually want to find defects as early as possible. And what you can see here is that if we put build automation in, if the build fails, then we know we've got a bug. If we've got continuous integration, then we know we've got an integration bug, and we will find it automatically as soon as we do our unit and integration tests. And down here we can see we can use test-driven development and behavior-driven development to actually drive the testing ahead of the development. Now, this model is a model that I produced about 6.5 years ago, and it was to predict the future. So one of the ideas of lines of innovation is, if you actually look at the innovations we've got available to us that have happened already, what might be the next thing that happens? So this prediction was for people testing over here on the far right. And the idea of people testing was that, based on the idea, although of course this is put a long time before the fourth industrial revolution, but based on the idea that there were going to be lots of people with not much work to do because the robots were taking their jobs, we would have lots of people who were moderately skilled with spare time. And we would build into virtual environments, we would build collaborative games so we could get small groups of people to actually test systems for us and be rewarded inside those virtual worlds. So this was a form of gamification, but before gamification was actually a common term. And down here you can see I'm trying to be very hopeful that the people that actually do it on the basis that they're doing it for the good of society rather than getting paid. But in reality, they're probably going to want to get paid, And if they get paid and they get good at it, then it might allow these people to bridge that gap, jump from the bottom, the low pay area, into the highly skilled area where they can start testing the AI and the robots. And AI is going to be an enormously big thing in the near future. Now, as you can see here with these lines of innovation, I've put AI and big data at the top there. I want to really concentrate on the AI because whether or not that we need too much data is open to debate. But over time, we will end up with lots of data if we follow any of these approaches. And the idea is that we use AI to try and make a number of different testing activities smarter and more automated. Now, AI has been around for about 60 years, but just over the last couple of years, AI is now becoming practical. All of you have got iPhones, will have Siri. If you've got a Samsung phone, you'll have S-Voice. If you've got Windows 10, you've got Cortana. These are all based on AI. They now have really good speech recognition. And not only that, the speech recognition turns it into words. Somewhere in the background is now natural language processing that is making sense of those words. And then there's something behind that that then satisfies your request. AI now is possible. It's even possible for very small organisations because you can license the technology from the big players. If you're one of the big players, you'll probably build your own AI. But if you're a small organisation with 5 people, you can still do this because you can license the technology. Things like IBM Watson, Google TensorFlow. The technology is out there, available, and it works. So here we can see we can build AI into these different testing activities, and that generates these assistants, this smart testing, and if we could combine all this together, we would end up with a really smart test manager's assistant. Finally, well, I've already mentioned it, natural language processing now works. If we can combine that with error guessing AI and specifications, then typically at the acceptance level, you can imagine giving the computer a natural language specification in Korean or in English, and the system interprets it and looks for inconsistencies, looks for conflicts, and tests it for us and takes out lots of the work that we would have had to have done manually in the past. And if it can do that, and we feed it in the ability to do test automation, which we have been able to do for decades now, then potentially we can now generate the test cases. And the automation obviously could execute the test cases for us. So, in conclusion, fourth industrial revolution, I don't think we can avoid it. If we try and avoid it, we will survive maybe 5 years, and then the technological advances will mean that we don't survive any longer. It affects us as individuals, it affects our businesses, it affects the standards makers, and it affects the government. Everyone is involved, because if people like the government don't support the businesses, then it won't work. I've shown you some lines of innovation. The lines of innovation can be used 2 ways. One way to understand our current situation. How did we get here? Because a lot of the time we just follow the rules and don't think about why. Why did we do that test process improvement? What's the basis for it? But more importantly, if we look at lines of innovation, we should, if we open our minds, be able to come up with new innovations and investigate those and push our industry forward. So, if you want more of these pictures. At the start of the slides is my web page. There are more lines of innovation there. And if anyone has any ideas on how I can improve the lines of innovation or come up with new innovations, please contact me. Thank you.
네, 안녕하세요. 저는 중앙대학교 심리학과에 재학 중인 이재환이라고 합니다. 네, 강의 너무 잘 들었고요. 근데 한 가지 궁금한 게 이렇게 계속 혁신이 일어나고 기술 발전이 일어나는데 그 중에 정말 좋은 혁신도 있지만 좋지 않은 혁신도 있다고 생각을 합니다. 그랬을 때 그런 거를 구분하는 혹시 뭐 노하우라든지 아니면 그런 게 있을지 궁금합니다.
I think this is always a problem with new technology and new innovations. I think we just have to hope that legislation keeps up with the innovations, and we allow, and the government keeps us safe.
You may heard about the recent accident of Tesla Model S, the autonomous driving problems. I believe that a few days ago, the Tesla Model S kills the drivers, you know. The Industry 4.0 can very impact about the software quality, I think. How do you expect, or how do you imagine the future of the software quality for Industry 4.0?
I think the Tesla problem will obviously be investigated, and it's very sad for the person and his family. It also appeared from what I read that it was possible to get a Tesla car to drive extremely fast with no human input. So while watching a video of Harry Potter. So I'm not sure that the technology and the software quality will actually help us in those respects. I think it's much more likely that legislation as to what we allow the technology to do is going to help us in those areas. We have very good software testing, software quality technology for safety critical functions already. We build airliners that fly billions of miles with no failures due to the software. So in that respect, I don't think we have a problem. I think we have a problem in controlling the technology and the use of the technology. I'm not sure that's really a quality problem.
네, 더 이상 질문 없으시면 마치도록 하겠습니다. 네, 시간 관계상 그 다음 순서 진행하도록 하겠습니다. 4차 산업혁명과 소프트웨어 공학에 대해 강연해 주신 스튜어트 리드 박사님께 다시 한번 큰 박수 부탁드리겠습니다.